Isomerism, structural stereotypes and examples. The phenomenon in which two or more substances having the same molecular formula possess either different chemical structure or different spatial arrangements of atoms or groups is called isomerism, and such substances are called isomers. Isomerism is quite common in coordination compounds. They exhibit both type of isomerism, that is structural isomerism as well as stereoisomerism. The structural isomerism comes into existence due to their different ionization behavior, difference in the position of ligands. On the other hand, the stereoisomerism originates due to the different stereochemical disposition of ligands around the central metal atom or ion. Coordinate compounds may show both type of stereoisomerism, that is geometrical as well as optical isomerism. Let us discuss the first one, structural isomerism. In structural isomerism, two or more complex compounds having the same molecular formula possess different structural arrangement. There are 5 types of structural isomerism. First one, ionization isomerism. When the coordination compounds having the same molecular formula show a difference in their ionization behavior and furnish different types of ions in solution, the phenomenon is called ionization isomerism. Ionization isomerism comes into existence due to an exchange of groups between the coordination and the ionic sphere. For example, a formula of CONH3 5 times BrSO4 can be written in two ways as two different coordinate complexes. The first one is COBrNH3 5 times SO4. Now this SO4 is the ionic sphere and this COBrNH3 5 is the complex coordination sphere. When it ionizes, this SO4 goes into solution as ions, that is, and this compound got a red violet color and its IUPAC name can be written as pentamine bromido cobalt 3 sulfate. Another complex possible is COSO4 NH3 5 times Br. Now ionic sphere is Br and coordination sphere is this compound, this complex. Therefore this solution, when it goes into solution as ions, they will give the characteristic test of Br only. This compound, when it ionizes, that gives the characteristic test of sulfate only. Therefore, even though the molecular formula is same, these two complexes shows entirely different even chemical properties and in the compound naming as well as the structure. The ionization behavior of these complexes is quite different. They ionize in solution as given. That means this compound, when it ionizes, SO4 ions will be present in the solution and give characteristic test of SO4 2 minus ions. Whereas this compound, when ionizes in solution, that gives the characteristic test of Br only. Therefore, the complex is the first one, that is red violet in color, and its aqueous solution gives a white precipitate of barium sulfate with barium chloride, thus confirming the presence of SO4 2 minus ions in the solution. Sulfate confirmatory test is that any solution which can give a white precipitate with barium chloride, that solution contains SO4 2 minus ions. On the other hand, the complex which ionizes and forms Br minus in solution, which is red in color, and its aqueous solution gives a light yellow precipitate of silver bromide with silver nitrate, thus confirming the presence of Br minus ions in its solution. This is Br minus or bromide ion can be tested by means of silver nitrate. When silver nitrate solution is added to the solution which is suspected to be containing Br minus ion, if it gives an yellow precipitate, surely indicates the presence of Br minus. Therefore, these two characteristic tests are entirely different for two different compounds. For the examination point of view, when you test for sulfate for the compound, the same test should be used for this compound also. For example, AgNO3 test is used for to identify these two. The compound which contain Br gives a yellow precipitate, whereas the other compound a negative test. That means it will not give any yellow precipitate showing the presence of bromide ion. Similarly, barium chloride solution is used for the sulfate ion. Barium chloride gives a white precipitate with this compound, whereas the other isomeric form is not responding with this test and no precipitate is formed. That is the way that you have to identify the two isomeric forms. Some other pairs showing this type of isomerism are, there are three examples are given. Look at the three examples in which the ionic sphere is different. Here this gives the bromide ion test, whereas this gives the chloride test. This gives NO2 test. This gives chloride test. And the third compound gives sulfate test, whereas this OH minus ions are present in the solution. This is the summary of the hydrate, the isomerism which is shown, that is ionization isomerism, the description and different types of isomers.